So I'm going to go over this geometry unit 4 test review on this video today. And so what I'm going to do for these first definitions and properties is I'm going to draw these because I think it'll help you guys to see what I'm talking about. So first of all, a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So I'm going to draw this out here. So both pairs of opposite sides being parallel means it has arrows on opposite sides indicating that these sides are parallel. Now the next property that we have here is that opposite sides are congruent. So we indicate that with tick marks. So this is a pair of opposite sides and they're congruent. And this is a pair of opposite sides and they're congruent. Notice that I don't have the same number of tick marks on those sides because not all four sides are congruent. Only opposite sides are congruent. Then we're going to talk about arcs for angles. So these are opposite, it says opposite angles are congruent. Those are opposite angles, and so I gave those one arc, and these are also opposite angles here, and so I gave those two arcs each. Now the next property we have on here is that consecutive angles are supplementary. So for this one, I'm just going to throw some values up here. So I'm going to tell you that this angle up here is 100. And consecutive angles mean angles that are next to each other. So both of those one arc angles are consecutive to that two arc angle up there with 100 degrees. So supplementary means that when I add them together, they equal 180. So for me to find this, I could go 180 minus 100. That equals 80. So this angle down here is 80. And this angle up here is 80 because they're both next to the 100-degree angle. Then the two arc angle down here at the bottom right is supplementary to both the 80, and 180 minus 80 is 100. So these would be, this angle down here would be 100 degrees. That's what it means by consecutive angles are supplementary. Now the next property that we have here is that the diagonals bisect each other. So bisect means, first of all, diagonals go from angles that are opposite angles. And then bisect means that those diagonals cut one another into equal parts. So this first diagonal we have here was cut into two equal parts, and I indicate that with my tick marks. And then this other diagonal was cut into congruent or equal parts as well. The last property that we have up here for a parallelogram is that if one pair of sides is both congruent and parallel, then it's a parallelogram. So now the next thing we're going to talk about is a rectangle. So the first thing we have to realize about a rectangle is, by definition, it's a parallelogram again with four right angles. So a rectangle is still a parallelogram, but it has four right angles. And so we need to recall that all the properties that apply to a parallelogram apply to a rectangle. Now it's got four right angles, but it also has two diagonals. So this diagonal that I drew from one angle to its opposite angle and this diagonal are congruent. So if I told you that one of those diagonals was 10, then the other one would be 10 as well. Our next shape is a rhombus. So again, it tells us to define it and to tell the properties of it. So the definition of a rhombus is that it is a parallelogram with four congruent sides. So I'm going to do my best to draw something that has four congruent sides. And I'm going to indicate that with tick marks on all four sides. Now, a rhombus has two properties that apply to it that have to do with its diagonals. So diagonals, again, go from opposite angles. And in a rhombus, the diagonals they're perpendicular. So they create four right angles in here. So all four of those angles would be right angles in there. Now, the other thing that a diagonal does in a rhombus is it bisects the angles of the vertices. So this angle up here is being bisected by that diagonal. So if I told you that this angle up here was 60, then if it bisects it, then each of these parts is 30. And the property is, again, all the properties of a parallelogram are true here. So if this angle up here was 60, then this angle down here would be supplementary to it. So that angle would be 120. And again, the diagonal bisects both of those. So this would be 60 and this would be 60. So those are the properties of a rhombus. Now the next one on here is a square. And with a square has all the properties of a parallelogram, a rectangle, and a rhombus. So basically all the properties that we've learned up to this point apply to a square. The next we're going to talk about is a trapezoid and an isosceles trapezoid. So first of all, a trapezoid is a shape that has a pair of parallel sides. So a trapezoid means this side and this side are parallel. And then these are, so those parallel sides, we call those bases. Sorry, that wasn't a very good arrow. So those are what we call bases. And then these two things on the sides, this over here and this over here, are what we call legs. So this is a base, and this is a base, and this is a leg, and this is a leg. Now, when we talk about a trapezoid, it has one pair of parallel sides. Now, one of the unique things about this is that at either end of these legs, these angles are supplementary. So again, if I told you this was 60, then this one would be 120. If I told you all this one was 90, then this one would be 90, because supplementary means they add up to be 180 degrees. Now let's look at an isosceles trapezoid. So an isosceles trapezoid is a trapezoid, again, that has a pair of parallel sides. And let's extend this a little more. But these legs over here are congruent too. Now, so on this one, our base angles, which are the angles that are either end of our bases, these are congruent. And the angles up here are congruent because, again, they're at the ends of the bases. So if I told you all this was 100 degrees, then this angle over here to the right is 100 degrees. And down here on the left, again, remember these two angles have to be supplementary. This angle down here has to be supplementary with 100, so this one will be 80. And those two are congruent, so they would be 80. Now the other property that applies to this is that the diagonals are congruent. So those are the properties of a trapezoid and an isosceles trapezoid. Now I'd like to talk about the definition and the properties of a kite. So first of all, the definition of a kite is that it has a pair of consecutive sides that are congruent and another pair of consecutive sides that are congruent. That's our definition. Then we have some properties that we could say about kites. So kites have diagonals that are perpendicular. So once again, they have right angles all in here. And where the non-congruent sides intersect, they have a pair of congruent angles. So these angles that are opposite right here are the same measure. Now, all quadrilaterals, sum of their angles is 360 degrees. So if we start giving some measures to some of these angles, then we can find the values of them. Now also, the diagonal that goes from the congruent, between the congruent sides, it bisects this other one. So this is congruent with this over here. So again, the diagonal that goes from between the two sides that are congruent to the diagonal when it cuts the other diagonal in half, essentially. I guess I can't talk today, so hopefully y'all understand that by seeing the drawing. Now let's give some angles here. So if I told y'all this was let's say 150 degrees, then this angle over here is 150 because they're congruent. And then let's just say this angle up here is 20. Then what we would do to find this is add 150 plus 150 plus 20. That's going to be 320, and we're going to subtract that from 360 degrees. So our other angle is going to be 40 degrees down here. That's what that angle is going to be. So what I'm going to do for number 7 is I'm going to read you all the problem, and then we're going to fill out this drawing because I think it will help y'all to see me do this to figure out what to do as you're working through this problem. So it says a pentagram is used to copy drawings. Its legs form a parallelogram in parallelogram JKLM. So LM is already given to us up here. It's 26. And what we know is that opposite sides in a parallelogram are congruent. So I'm going to put 26 over here as well because opposite sides are congruent. Then the next thing it says on your paper is that KL is equal to 50. And that's already marked. And we know again that opposite sides are congruent. So I'm going to put 50 down here as well. So opposite sides are congruent. The next thing on here says that LJ sorry, it says that KO is 17. So KO is from here to here, so this length right here. And if that's 17, then the other portion of it is 17 as well. So this is 17 and this is 17 because diagonals bisect each other. Then we have that LJ, which is the whole length of the other diagonal, is 72. So I'm going to do 72 divided by 2, and I'm going to go ahead and mark what that length is too. So that's 36. So that means this is 36, and this one is 36. So now we've dealt with all of our side lengths and our diagonals, and we're going to move on to angles now. So the next thing it gives me in this problem is that LMJ is 140 degrees. Well, LMJ, I'm going to go ahead and mark it here. LMJ, that's this angle down here. So we're going to talk about LMJ. Sorry. I want to go ahead and erase this so that we can work through this problem and not get confused. So LMJ is this angle down here, and it told us that it was 140 degrees. Well, we know that opposite angles are congruent, so this angle down here is congruent with this angle up here, so this one up here is also 140 degrees. Now, the other thing we know is that in a parallelogram that consecutive angles are supplementary. So that means we know that J over here and L up here are supplementary to the 140, and that means 180 minus 140, that those two angles are both 40 degrees. So once again, we're going to go ahead and mark these as 40 and 40 so that we know what the measures of these angles are, 40 degrees and 40 degrees. And we're going to put 2 arcs here and 2 arcs here because we know that to be true as well. Now, if you guys notice where we have the 40 and the 140, we have portions of those angles. So we could use our angle addition postulate to solve for what's missing. So here again, if you notice down here, we have 140. Sorry about that. So we have the 140 down here. So we could subtract the 60 from the 140. So 140 minus 60, that's 80. So that means that this portion of this angle right here is 80 degrees. So let's go ahead and do this on this other one over here where the 40 is. So 40 minus 15 equals 25. So this is 25 degrees over here. Now, I noticed something that you guys may or may not notice, and I noticed that I have some alternate interior angles in this drawing. So over here, I have that this angle, this 60-degree angle, is an alternate interior angle with this angle up here. So that means I know that this angle up here is 60. I also noticed that this angle right here, this 80-degree angle, has an alternate interior angle up here, and that is also 80. Same principle is going to apply over here where I have the 25 degrees, and over here again, down here is where the 25 degrees is going to go over here because that's its alternate interior angle. Then we have the 15 right here, and its alternate interior is up here, and that's 15. Now the only angles that were left that we don't have right now are these angles at the intersection of the diagonals. So let's see if we can figure out what those angles are. So if you notice up here, we have this triangle. And we know by the triangle sum theorem that we can find that third angle because when we add all three angles together, they should be 180 degrees. So we could do 60 plus 15, that equals 75, and then we could subtract that number from 180, and that tells us that this angle is 105 degrees. So this angle right here is 105, and its vertical angle right across from it is 105 as well. Now there's two ways that we could solve for those other two angles. We could use the triangle sum theorem again, or you could notice that this is a line and this is, and when I have this line and this, they form a linear pair. So I could do 180 again minus 105. That means that other angle is 75 degrees because they are a linear pair. So if that's 75, then its vertical angle is 75. Now you'll notice that we have answered literally every part of this drawing has what is necessary for us to answer the questions. All of that's already done. So we're going to now go back and read the questions and answer all of them. So now that we have all these parts filled in, we're going to go ahead and see if we can find what it's asking for. So the first thing it asks up here us for is JM. And let's see if we can find JM. JM is down here, and that is 50. So we're going to go ahead and write that as 50. KJ is this side over here, and that's 26. OM is right here. So we're going to say that one is 17. That's what it's marked. KM is the whole length, and that's 17 plus 17, so that's 34. That was the whole thing right here, y'all. Then we have JO and JO. Okay, JO's right here. JO, that's 36. OL is this part right here. It's also 36. Then we have OM, and I think that was supposed to be OK, y'all. But we already had OK up here. If you notice, it was one of the things, or KO. It was 17, but otherwise it would be still 17. If we were, then we are looking for angle JKL. So angle JKL, let me go ahead and draw this in a different color. JKL. JKL is this angle up here. So that one's 140. Then we have angle, so that was 140, sorry. Where was I at? JKL. Oh yeah, it's 140 up there, okay. So then we have angle MJK. So let's see if we can find another color. MJK. So MJK is MJK is this angle right here, and it's 40. Then we have MLK. MLK is MLK. So it's this one right here. It is also 40. Then we have LJK. We'll go with another color, y'all. LJK. LJK. So LJK is this angle right here. And its measures right there. So that's 25. Then we have LMK. And LMK is this one down here. LMK goes up there. So that's that measure right there, which is 80. Then we have JKM. Gonna switch colors again, y'all. JKM. So again, J is down here on the left corner. K and M. JKM is this angle right here. JKM. So we're talking about that measure right there. So that's 80 degrees. MKL. MKL. MKL is this one up here. And this one was 60. Then we have KLJ. KLJ. So I'm going to go with another color again, y'all. KLJ is this angle right here. KLJ. So that's 15. Wait. KLJ. KLJ. KLJ, yeah, it's 15. And MLJ, my initials. Let's go with blue for this one. MLJ. So MLJ, M to L to J. So that one's 25. So there we go. So for this problem, this is number, I don't know what number it is, but it's the next set of problems. So it says, it's number 8, Roman numeral 8. W, X, Y, Z is a parallelogram. Find each value and measure and explain. Okay, so on this one, again, we need to mark what we know. So this is the first thing we know. We know the opposite sides are congruent, so we can do something with those. We know that these two angles are congruent because they're opposite angles. And we know that X and W angles are supplementary. So since it's asking me to solve for A first, I'm going to go ahead and set this up with these supplementary angles, adding them together, and then going to set them equal to 180. So I'm going to combine my like terms. That's 8a minus 12 equals 180. When I add the 12 to both sides, that's 8a equals 192. When I divide the 8 into the 192, I get a equals 24. So that's my a up here. That's 24. Then it's asking me to solve for b. So when I solve for b, I'm going to go back in here and I'm going to set these two congruent sides equal to each other. So that's 6b minus 7 equals 10b minus 19. When I combine my like terms here, when I move the 6b to the other side, I subtract from both sides, I get 4b. When I add 19 to both sides, I get 12 over here. And when I divide the 4 into the 12, I get that b equals 3. So our b equals 3 up here. Then we have to solve for c. Now to solve for c, I'm going to have to solve for angle W. And we had that a was equal to 24, so we can solve for angle W. So angle W, and the reason we have to solve for angle W, by the way, is because it is congruent to angle Y. And the measure of angle Y is 4c minus 1. So we're going to do 3 times our 24, and then we're going to add 27 to that. 3 times 24 plus 27 equals 99. So we now know that this measure of this side right here is 99, and those two angles across from each other are congruent. So that means I can say that 99 is equal to 4c minus 1. If I add 1 to both sides, that's 100 equals 4c, so c is equal to 25. So our c is equal to 25. Now all we have to do to find what's missing, the wx, the yz, the angle x, and the angle w, well, we already find the angle w, so we can go ahead and write that. That was 99 degrees. Everything else, all we have to do is plug in our values to find it. So wx, we would plug in our b for that. So when I'm solving for wx, that would be 6 times 3 minus 7. And 6 times 3 minus 7 is 11. So wx is 11, which means yz would be 11 as well, because they're opposite angles. So we could just say that, or we could prove it by filling it in. But then measure of angle x, we have 5a minus 39. So the measure of angle x equals 5 times 24 minus 39. That equals 81. And the way we can check that is that 81 plus 99 equals 180. And so we know that those angles are supplementary because when we add them together, they equal 180. So now we're on number 9. properties of special parallelograms. The flag of the Jamaica is a rectangle with stripes along the diagonals. In rectangle QSRT, QS is 80.5, QS is a diagonal, and RS is 36. So we know that QS, that's this right here, is 80.5, and that RS, that's this side over here, is 36. So we know if this is 36, we know that this is 36 because opposite sides are congruent. And we know if this diagonal, the first diagonal we drew was 80.6, this whole thing, this was 80.6, then we know that this one here is 80.6 as well. So it says to find each length. So SP is part of one of our diagonals. So both diagonals, because it's a rectangle, are congruent. So SP is down here, this one right here, sorry. SP is right here. So we can do 80.5 divided by 2. That's going to tell us what the length of that diagonal is, and that is 40.25. So this diagonal is, or this part of this diagonal, I should say, is 40.25. And then QT is just a side. We've already got that marked. That's 36. TR is a whole diagonal, and all the diagonals are congruent, right? So this one is 80.5 as well. And then TP is, again, a part of a diagonal. And half of 80.5 is 40.25, so that one is 40.25 as well. Now the next problem on here is GHJK is a rhombus. Find each measure. So first of all, we know what our properties of a rhombus are that all of our sides are congruent. So we're going to put tick marks on all our sides. And we also know that the diagonals bisect angles and that the diagonals are perpendicular, meaning all those angles at L are right angles. So first it's asking us to find the length of HJ. Well, to find that, we can set the two sides that we have equal to each other. So we could say 6a minus 7 equals 3a plus 9. Going to subtract 3a from both sides. That gives me 3a over here. Going to add 7 to both sides, and that gives me 16. And then I'm going to divide 3 into 16. So a is equal to 16 over 3. Then, when it asks me to find HJ, I just got to plug that value back into one of my sides. So when I do that, if I plug it back into GK, I do 3 times 16 over 3, and then I add 9 to that. Well, these two 3's cancel each other out, so that's really just 16 plus 9, so that's 25. So HJ is 25 because all the sides are 25. So now we're going to find these other two angles. So we're looking for HJG and GHJ. And we're given the measure of HGL and KLJ. So HGL is up here, and this one is 4b minus 6. And then we're given KLJ, or KJL, sorry, KJL, that's down here, and that one is 2b plus 11. Well, what I want to show to y'all is that we got a pair of parallel sides here, right? Here. I don't know what happened there. We got a pair of parallel sides here, right? And then we got this, which we would call transversal. So this angle is congruent to this angle up here, isn't it? And that means we can set those two angles equal to each other. So that's what we're going to do. We're going to set those two angles equal to each other because this angle right here is congruent to that angle right there. So we got 4b minus 6 equals 2b plus 11. Subtract 2b from both sides, so that gives us 2b over here. Add 6 to both sides, that's 17. And 2 goes into 17, so this is 18. 8.5. So 2 goes into 17, 8.5. Okay. Now, for us to find those angle measures, we got to plug those values back in. So let's go ahead and plug 8.5 back into this one right here. So that's 4 times 8.5 minus 6. let's see if I can find 4 times 8.5 minus 6, that equals 28. So that is this angle up here. So this is 28. And that other angle ought to be 28 as well, KJL. So let's just make sure it is. So 2 times 8.5 plus 11, 2 times 8.5, that would be 17 plus 11. Yep, that's 28. So both of those angles are 28, so we know we got the right answer. Then this is a rhombus. So in a rhombus, if each of these are 28, then the ones next to them are 28. So these would be 28 as well. And 28 times 2 is 56. So we know that the angle G up here, this angle is 56, and this angle down here is 56, which means we could find K and H because they are supplementary angles. So we could do 180 minus 56. That means that angle is 124 degrees here, and this one up here is 124 degrees. Now those angles too are bisected. So we could divide that by 2 to find those individual parts if we needed them. I can't remember whether we need those or not. So no, we don't. So let's just look at what this is. HJG. So HJG, let's do that in red. HJG, HJG. So that's this part right here. We found out that that was 28. So this is 28. And then GHJ. GHJ. So let's do this one in blue. Whoops, sorry. Okay, stop that. So I'm going to try it again, y'all. GHJ is this angle right here. So that's 124. So again, working through the drawing and getting everything right there first helps us to get the right answers when we write them down. Now we're on number 11. So number 11A is a kite, and I know that because it has 2 pairs of consecutive sides that are congruent to each other. So with a kite, we know that angle A and angle C are congruent because they are between the non-congruent sides. So we know that angle C is 110 degrees. So we got that answer right there. Boom, done with that one. When we're looking for angle D, we can add those 3 angles together. 90 plus 110 plus 110. And then subtract that number from 360. So that would be 220. What is that? 310. So 310. And so 360 minus 310 equals 50. So this angle down here would be 50. And 50 plus 90 is 140. 140 plus 220 is indeed 360, so we could check it too. So then the only other thing that we need to find here, so that was 110 and the other angle down there was 50. So now let's go ahead and find x and y. So we know that these x's are equal to each other here, so we set them equal to each other. X plus 5 equals 3x minus 30. Subtract x from both sides, that gives me 2x over here. Add 30 to both sides, that gives me 35. So x is equal to, I think that's 17.5, yes. Okay, then down here also we're going to set these y's equal to each other. 1/4 y plus 4 equals 3/4 y minus 4. So now I'm going to subtract 1/4 from 3/4, and that gives me 1/2, or 2/4. So that would be 2/4 y. And then I'm going to add the 4 to both sides. That equals 8. So 2/4 is the same as 1/2. So this is 8 equals 1/2 y. And when I'm trying to get rid of a 1/2, I multiply both sides by its reciprocal, which are 2. So y here is equal to 16. So our x was 17.5 and our y was 16. Okay, now we're on letter B. So it says find x in the length of VX, RT, and QU. So again, what we have to realize first is when we're talking about this point in the middle, if you know, I mean the dashed line here, the 5x minus 1 line, it is a mid-segment. So we know that QV, if you notice we got these tick marks over here, so QV and VU are the same, so we could put 7 up there. And we know that RS over here, we got 2 ticks here and 2 ticks here, so this is also 10.5. So it says find X. So to do that, we have to use our midpoint formula. So our our mid-segment formula, sorry, 21 plus 27 divided by 2 equals 5x minus 1. So how would we normally get rid of that 2? We would multiply both sides by 2. So we multiply both sides by 2. That gets rid of the 2. So we got 21 plus 27, that's what, 48? So we're going to go ahead and write 48 here too while we do this step. So 48 equals 10x minus 2. I'm going to add that 2 to both sides. So that gives me 50 equals 10x. So x equals 5. So that's our value for x. X equals 5. And then when we're trying to find the rest of this stuff, VS, we just plug 5 into there. So 5 times 5 minus 1, that's 25 minus 1. So this is VS equals 25 minus 1 is 24. So that's VS. RT is the whole length of this. And so we've got for RT, we're just going to do either 2 times 10.5 or 10.5 plus 10.5. So that's going to give us 21. And then our last value that it's asking us for is QU, and that for QU, that's going to be 7 plus 7, and that's 14. So those are all our values that we needed for over there. Now we're on letter C for number 11. We're supposed to find W, X, Y, and Z. So here it appears that this is an isosceles trapezoid because we have a pair of parallel sides, EF and HG, and then we have 2 legs that are congruent, EH and FG. So when we're trying to find these angles, we know that base angles in an isosceles trapezoid are congruent, and so these angles are congruent to each other. So we know that angle X, or the measure of X is equal to 61 because those angles are congruent. We also know that E and H are supplementary. So if we were trying to find Y, we could just do 180 minus 61, and 180 minus 61, let's see what that is. That equals 119. So that means if Y is 119, then Z is also 119 because those angles are congruent. Then we need to find what W is, and those 2 legs are congruent. So we're going to set those parts equal to each other. So we have 2W plus 7 equals 6W. I'm going to go ahead and erase this if it will cooperate. 6W minus 9. So I'm going to subtract 2W from both sides, so that gives me 4W over here. Add 9 to both sides, so that gives me 16. So W is equal to 4 because 4 into 16 is 4. So now we have number 12. So on number 12 it says decide whether the statement is always, sometimes, or never true and circle the correct answer. So the first one, letter A, says a parallelogram is a trapezoid. This is never true because the definition of a trapezoid is that one pair of sides are parallel. So this is C. And then the next one is a parallelogram is a rhombus. Well, that's sometimes true because a rhombus is a parallelogram, but a parallelogram is not necessarily a rhombus. So then letter C is a rectangle is a square. Again, this is sometimes true. A square is a rectangle, so a rectangle could sometimes be a square because the definition of a rectangle is that it has 4 right angles. Then letter D is a square is a rhombus. Well, a square is always a rhombus because a square has 4 congruent sides, so that's letter A. The last one is a kite is a parallelogram. Now, this one is sometimes true because a kite has 2 pairs of consecutive sides that are congruent, and that's true of a rhombus. And a rhombus is a parallelogram, so letter E could be sometimes. Okay, so now we're on number 13, and number 13 has to do with an exterior angle. This is our exterior angle, and what we learned when we learned this, the exterior angles theorem, is that these 2 remote interior angles here, these 2 angles here and here, when they're added together, they equal the exterior angle. So that's exactly what we're going to do here to find x. So we're going to do 4x plus 2 plus 2x minus 9 and set that equal to the 5x plus 13. So this is 6x minus 7 equals 5x plus 13. Then we're going to start moving our stuff, our x's to one side. So 5x from 6x, 6x minus 5x is x, and we're going to add the 7 to both sides. That's x is equal to 20. Now it's asking us to solve for angle J down here on the right. So that's this angle over here, right here, and that's this value. So we're going to plug that 20 into that one. So 2 times 20 minus 9. 2 times 20 is 40, and 40 minus 9 is 31. So the measure of that angle is 31 for angle J. So the measure of angle J is equal to 31. Now we're going to work over here on number 14. What type of quadrilateral is ABCD? We're supposed to ask us that first, and I happen to notice immediately that all 4 sides are congruent and there's no right angles. So if I was going to call this something, I'm going to call it a rhombus because all 4 sides are congruent. Then it asked me to find the measure of angle A and the angle B and BEC. So the measure of angle A, first of all, one of the rules with respect to a rhombus is that the diagonals bisect the angles. So that means if this part up here is 33, then this part right here is 33, and I could add those 2 together to get C. So C would be 66. Same way down here with D. If this part right here is 57, then this part right here is 57. And 57 plus 57 is 114. And we'll notice immediately that these 2 angles are supplementary, and they should be. So then it's asking me for what is the measure of A and B, and measure of angle A is congruent to the measure of angle C. So the measure of angle A equals 66 degrees. And the measure of angle B is congruent to this angle down here at D. So the measure of angle B is equal to 114 degrees. Now the last thing that this problem is asking us for is the measure of angle BEC. So the measure of BEC, now what I remember about rhombuses is that their diagonals are perpendicular. That means all of these angles in here are right angles. Thus, the measure of angle BEC is 90 degrees. Yes, finally, our last problem. So this one is number 15. So it says, given that angle Q and T are congruent and R and U are congruent, what other piece of information is needed to show that triangle PQR is congruent to triangle STU? So I'm just going to draw 2 triangles and label them PQR and STU. So PQR and STU. Then I'm going to mark these angles that it tells me are congruent. So it says Q and T. So Q is congruent to T, and angle R is congruent to U. Angle R is congruent to angle U. Now it's asked me to prove that these 2 triangles are congruent by angle, angle, side. Now this one is unique only in that it actually has 2 different answers. So if I start with Q, Q here, and then I go to R down here, and then to the side, I would be talking about PR. Now I'm going to move the same direction in the other one, TU, and then I would be talking about this side down here. So if I moved from Q to R and then the side, and T to U and then the side, then I would be talking about side PR is congruent with side SU. Now, if I don't move that direction, but I move the opposite direction, then I'm going to have a different answer. So let me go ahead and erase this so you guys can see what I'm talking about, maybe. So here again, we have our arcs, right? So these are two arcs, and there's two arcs over here. So we have, this time, if we go from R to Q, so if we go from R to Q, then we're talking about this side over here, PQ. And over here, again, if we go from U to T, then we're talking about this side over here. So this problem actually has two answers. Won't be that way on the test. But so then we could talk about PQ is congruent to ST. And again, this is by angle, angle, side, because if we start here, angle, angle, then side, angle, angle, then side. So those are the two possible answers that you could have gotten for number 15.